Hi everyone, my name is Tim Kington and this is Coding is for the Birds. This is the Java for Beginners series. Last time we talked about switch statements and we wound up with some code that was a little bit ugly. It was kind of long, it was a little bit hard to read. Today we're going to talk about defining methods and calling them, and that's going to give us a way to break our code up and make it more digestible, make it easier to understand. It's also going to give us the ability for the first time to write unit tests. Let's take a look. Last time we took a look at the switch statement, and we built a little menu to show off how a switch statement works. So we printed some options for the user, we read a choice from the user, and then we did a switch based on that choice. And then in each switch, we wrote some code to do something trivial. So we asked for a couple of numbers and added them together. We asked for a number and printed double the number. We asked for a number and checked to see if it was a large number. This code isn't too terrible. It fits on one screen and it's not that bad to read, but you can imagine that if we were doing something real in these cases, the code would quickly get too large to understand. You would be paging up and down and your code is indented 3 or 4 levels here because we're inside the switch. Maybe we're inside of an if as well. It just generally gets hard to read. So what can we do to make this more understandable? One of our main goals, almost our highest priority when we're writing code, is to make the code readable. So the first priority is make it work, obviously. But a close second is make it readable. If you can't read the code when you come back in a few months, you will not remember what you were doing. And obviously when you're working on a team, other people need to be able to come in and read the code. And it's much harder to read code that someone else wrote than to read code that you wrote. So we want to make our code clean and simple and easy to read. One thing we can do to clean this code up is to use methods. So far, we've been doing all of our work in the main method. And we haven't really talked about this definition of the main method very much, just to say that it was the entry point for our program and this is where execution began. In Java, we can write other methods in our classes. Let's see how that works. For now, all of our methods are going to begin with static. We'll get into the details of that more when we talk about objects. Next, they have a return type. This method isn't going to return any data. We're going to move the code that asks the user for 2 numbers and adds them together into this method. So we'll call it add 2 numbers. We're going to put this code inside the method. And down here in case 1, we will call the method. It turns out we've already been calling methods. We've been calling system.out.println. We've been calling in.nextInt. When we call a method, we can use an object and then a dot and then the name of the method if we're calling a method on an object. Some methods, static methods, don't need an object to be called. So when we call add 2 numbers, we don't need anything in front of it. We just give the name of the method and then the parentheses and a semicolon. When we run our code and we get to this line, execution is going to jump to this method. So we'll jump up to the add 2 numbers method, begin executing code with the first line of the method. We'll run this code normally. And then when we reach the end of the method, execution will return to where the method was called. So we're going to ask for 2 numbers, read them from the user, print the sum, jump back to this line, and then pick up with the next line of code. So we'll hit the break, jump to the end of the switch statement. Right now we do have an error here. If we look at this, we'll see that in cannot be resolved. So it's time to talk about variable scope. A variable scope in a program is the part of the code in which that variable is visible, in which it is defined. When we define a variable inside of a method, like we do inside our main method, the variable scope will begin at the line where it's defined, and it will extend to the end of that current scope. So if we define it inside our method like this, in is visible from here to the closing brace that ends our main method. When we define choice, choice is visible from here to the closing brace for the main method. If we tried to print choice on the line before that, we would get an error. Choice is not yet defined. I said that the variable scope goes from the point where we define it to the end of the current scope. That will not always be a method. For example, if we define a variable inside of a switch statement, like we did here with z, z will exist from this line to the end of the switch statement. Z is not actually visible out here in the main method after the switch statement ends. So if we look at this error, it says Z cannot be resolved. Our addTwoNumbers method can't find the variable in because it was defined inside main, and that variable only exists inside our main method. I'll go ahead and add another scanner into our addTwoNumbers method. We could make our scanner have a larger scope. There are various ways we could solve this problem, but the simplest thing to do for now is just create a scanner inside addTwoNumbers and use it just the way we have been. All right, let's see if this method call works. We'll run our code, and we'll enter choice 1. And then it asks us for 2 numbers and prints the sum. So the execution of our code doesn't seem to have changed. We can watch what's going on here if we go inside the debugger. So let's set a breakpoint and do that again. So we'll enter choice 1, and then we hit our breakpoint. And we can click step into to work our way through the code. We can see we go into case 1. Now if I hit step over at this point, we would run this line of code, which would call the method and run all the code inside it. And then the debugger would pause again when we had finished this method on the break statement. If we click step into, we'll go inside of addTwoNumbers, and we'll be able to watch what's going on inside that method. So we can step line by line through here. It prints enter 2 numbers, then it waits for us to enter a number. And then if we step again, it will wait for us to enter a second number. And now it's going to print the sum. We're also getting all kinds of garbage up here. So we can see what X and Y are, which is useful. Our scanner is not printing information quite so useful. So we're getting this Java util scanner with a bunch of extra information. We can ignore that. It's not a problem. It's just not telling us anything particularly helpful. If we step again, it prints out the sum is 9. Step again, it's going to close our scanner. And if we step one more time, this method is going to return. The method finished, and execution will go back to the point where it was called and pick up with the next line of code. So now we're on our break, which will then jump to the end of the switch. And now we're at the end of our program. Let's do that one more time, but this time instead of hitting step into, we'll hit step over. So we'll choose option 1, step here. Now if I hit step over, the whole addTwoNumbers method is going to run before the debugger pauses again. So it's asking for 2 numbers. I can enter 2 numbers. It prints the sum, addTwoNumbers return, and now the debugger stops on this next line. So that's the difference between step into and step over. Step into will go inside of any methods that we call, and step over is not going to go inside the methods. Typically, we're going to use step over when we think the method is working correctly and we don't need to go inside and see what's going on in there. We can simplify the rest of our code by creating a few more methods. So let's create one that doubles a number. We'll put this code in here. We're going to need a scanner in each of these methods. And I'll add in .close so we don't have warnings. And then we'll create a method for our check bigness option. And then the code for that will be this code. And down here in our switch statement, we can call our methods. So we'll call double number here. We'll call check bigness here. Get rid of my breakpoint, and we can run this. And we can see that our program still works. So double a number. We call the method. It does the same thing it did before. The difference here is that our code is better organized. When we read this switch statement, it's much easier to read. We say if the user entered 1, we're going to add 2 numbers. If they entered 2, we'll double a number. If they entered 3, we'll check the bigness. If we believe the names of these methods, we don't need to go inside them and read that code. So if we were working our way through the code trying to figure out what's going on, as long as these are named well, we can assume that we understand what's going on when we see them, and we don't need to go down inside the method and read the details of how it works, unless that's the thing that we're interested in. Maybe there's a bug when we try to double a number, so we know we're going to have to dig into this method. But if we were worried about something else that might be outside of these calls, we could just see the name, understand what's going on, and move on. So methods help us read the code because they let us collect pieces of code into chunks. And we can think about a chunk as one piece. That's a lot easier than when we had this code directly in the switch statement and we had to read through it line by line and try to figure out what it was doing. Now we have a nice name associated with that chunk of code, and we can think of it as one thing instead of a bunch of lines of code that we need to evaluate and concentrate on to understand. Another thing that methods let us do is perform the same thing more than once. Before we had methods, if we wanted to ask for two numbers and add them and then do it again, we would have had to repeat all of this code. So we could have copied and pasted that in our main method a few times. Now we can just call the method more than once. So this is going to do exactly what you would expect. We'll say add some numbers. It asks for two numbers. Oops, what did I do? Closing my scanner is causing us headaches. Okay, well, let's get rid of these. We can deal with the warnings. Once we close the scanner, I guess we can't really use it again. So if we say add some numbers, we can put in 1 and 2, and it prints the sum, and then it asks for two more numbers. So we can put in 5 and 6, and see the sum is 11. But we didn't have to write this code twice. We've written it once, and now we can use it as many times as we like. So that's another big benefit of methods. The methods we've written so far are atypical. They interact directly with the user. Most methods in Java are not going to do that. Methods will typically take some data in, do something useful with it, and then maybe return some data to the code that called the method. Let's write a method that is more like that. So instead of having an add two numbers method that reads numbers from the user and then does a calculation and then prints the results, let's write a method that just does the adding. We'll still define it as static. All our methods are going to be static for now. This method is going to need to take in two numbers, do a calculation, and then return a number to the user. The return type will be int. We're going to send an integer back to whoever called this method. We'll call the method add, and then we need a way to pass two numbers into the method so that it can add them. That's what goes in the parentheses here when we define a method. We can provide a list of parameters, which are basically variables, whose values will be supplied by the code that calls our method. So we need two integers here to add, so we're going to call one x and one y. You'll notice that the parameter definitions look a lot like variable declarations that we've seen already. We have a data type and then a name for the variable. When we want to send data back to whoever called our method, we use a return statement. So we'll say return, and then we provide the value that's going to be returned. In this case, since add's return type is int, this expression here needs to be an int. We're going to say return x plus y. Let's try calling this method. We can rearrange our code a bit. Let's get rid of the add two numbers method, and we'll use our new add method instead. So in our main method, we will ask for the two numbers to be added. Then we will call our add method, and we'll supply x and y, and we'll assign the result to a variable. And then let's get this code that printed the sum. We can go ahead and completely get rid of the add two numbers method. And here we can print our sum. I should also rename some of these variables. Let's call the variables inside of our add method a and b instead of x and y. I don't want you to think that there's any connection between the variable names outside the method and the variable names inside the method. So here in our case, we're going to read the numbers from the user as we did before. Print, please enter two numbers, read an int, store it in x, read an int, store it in y. Then we call our add method, and we pass in x and y. That means we jump up here. Whatever was in x is going to be stored in our variable a, and whatever was in y will be stored in our variable b. Now we're going to add the two numbers together, and then send the result back to the caller. So we're returning this sum. When we return a value from a method, that means that the value of the method call itself will be that number. So add xy will be equal to whatever that method returned, and we can then assign that value to the variable sum. Let's look at this in the debugger. Choose option 1. It asks us for two numbers. We'll put in 4 and 8. So we're at this point in the code. We're about to call our add method. You can see that x is 4 and y is 8. If we step in, we will jump into the call to add. Inside of add now, we have a variable a and a variable b that are our parameters. And you can see that they have received the values that we passed in. So the first parameter that was passed in was 4, and the second was 8. That means a is 4 and b is 8. In the variable window over here, we can see the values of these variables. We also have a call stack window here that we've been ignoring up to this point, but this will show us all of the methods that are currently active. So we have our main method, which was active, and then it called into our add method. If we want to, we can go back and forth between these calls to see what the variable values are. When we click on the main stack frame here, we see the variables that exist in main, like choice, x, and y. If we click on the add stack frame, we see the variables that exist inside of add, so a and b. We're now going to return a plus b, so 4 plus 8 will be 12. If we step, that value will be returned. Notice that we're still on this line, so we haven't quite completed this line of code. And in our local variable window, we can see the return value of add is 12. And this is about to be stored in our variable sum. If we step one more time, we'll see now that there is a variable called sum, and it holds the value that add returned. The value of a method call is its return value. So whenever we call add, its return value is going to be an int. We can see that the return type here is int. That means we can use calls to add anywhere that we could use an int. So we can assign it to an integer variable. We could use it in the middle of an expression. We could do something like this here. We could say add the numbers 3 or 2 and 8. Let's actually go ahead and get rid of the part that's asking for numbers right now. Make this simpler. So add some numbers. It says another sum is 10. Since we're just messing around with function calls at this point, let's go ahead and get rid of our menu and our switch statement. We can even have calls to methods inside calls to methods. We could do something like this. We could say add 2 and the sum of 8 and 3. So what's going to happen here? Before this call to add can happen, the virtual machine is going to have to evaluate each of its arguments so that those values can be passed into the call to add. The first argument is 2, but the second argument is another word for parameter. The second argument is a call to the function add. So first we need to call add with 8 and 3 to find out what this value is. This line is going to call add 8, 3, get the result back, then it's going to call add with 2 and whatever this result was, and that will return a value, and then it will take the string third and it will add it to the value that was returned, and it will print that out. So if we run this, we're going to see 8 plus 3 was 11, and then we added 2, and that gives us 13, and it prints out third colon 13. We can watch this in action in the debugger. It's a little bit confusing when you're reading the code, but we can see that this really is what happens. So here we are about to call add for the first time. We'll step in, and we went inside the string builder, so let's step out and step in again. That's because we're building a string to print out, so there's some extra things happening behind the scenes. So here's our call to add, where a is 8 and b is 3. And so this is going to return 8 plus 3, which is 11. We'll go ahead and step. So now we're back at this line again. We've returned from this first call to add. You can see that add returned 11 over here in the local variable window. If we hit step into again, we'll see that we go into add for a second time. This time a is 2 and b is 11. So we passed in the 2 that we had hard-coded and the 11 that was returned from the first call to add. Now we're going to return 2 plus 11, which is 13. And if we step, we'll see that add returned 13 this time. And that 13 is going to be added onto the end of the string, and it will be printed out. We can also make calls to methods from inside of other methods. Let's go ahead and get rid of these. We're not using them right now. Let's make a method called addThings and have it call add. So it can add 2 and 3 and print them out. Maybe we'll make it do these other additions that we had already written. And here in main, we'll call addThings. So what will happen when we run this? Well, we hit this line. If we hit step into, we go inside of addThings. If we hit step into again, now we're inside of add. This call stack over here shows us where a method was called from, and that's where it will return to when it completes. You can see here where we're in app.main, and over here on the right you can see 24:1. That means we were on line 24. Then it called addThings on line 16, and that line called add. We can see inside add that our variables a and b are 2 and 3, which are the values we supplied here. If we step again, we'll come back to this line of code, and then we'll print out 5. If we hit step into here, you can see that we make another call to add. Because we did it inside of the system out print line, we're first going to go into some code we don't care about. So we'll hit step out and then step in again. And we can see that we're inside of add where the values are 2 and 8 that we supplied here. If we step that, we'll return, and then we'll print out 10. And then we could go through these calls to add like we did before. So the fact that methods can call other methods gives us a lot of power. We can put different pieces together in pretty much any way we like. Now that we have method calls, we can take a look at unit testing. Our add method is very simple, but let's pretend it's some significant amount of code and we need to prove that it works. We can go into our project, and over here in our test package, we can add a class. So let's add a class called addTest. We're not going to worry too much about what classes are yet. We need a class for our tests, so we'll just do that. And then we need methods in here that are going to test various things. So let's add a method, and our test methods are always going to be public void. I'll call this test add. And in our test classes, we need to put an @test annotation on our test methods. This marks them as unit tests. So they're not normal code that will be used in our application. They are there to test other parts of our code. If I hit enter here on org.junit, this is going to automatically import the org.junit test annotation. JUnit is a very nice testing library for Java. It's used by almost everyone, and that's what we're going to be using here. It integrates really nicely with VS Code. So we have this method called test_add. We've got our test annotation so that the tools know that this is a test method. And then in here, we can run some code and see if it gives us the correct results. The way that we're going to express that in our test cases is to write assertions. So there are a bunch of different assert methods that we can use in JUnit. One of them is assert equals. You can see here that we're going to pass it the expected value and the actual value. And there are a lot of different versions of assert equals that take different types. There's one that will compare to doubles, one that will compare to floats, one that will compare to longs. These are data types we haven't really mentioned yet, but there's a version of assert equals for every primitive type in Java, one of which is int. So we're supposed to put in the expected value and the actual value. We're going to test our add method and make sure that it returns 5 when we add 2 and 3. When we want to call a static method from another class, we need to give the name of the class and then the name of the method. So we'll say in app.add, if we call add with 2 and 3, it should return 5. Right now we have an error here. It's telling us that app cannot be resolved. We can fix this. If we click quick fix, it will import our app for us from com.example. Now we're getting some other errors. The method add from the type app is not visible. We'll get into more detail about visibility later, but what that's really telling us right now is we need to make this method public. Then it can be seen from other classes. Finally, we have an error on assert equals. This also has a quick fix. We need to import our assert equals from the JUnit libraries. So the quick fix will take care of that by adding this line of code. And now our code is compiling. We can now run our unit test by going over here to the test package and clicking this play button. This will find the tests that we've written and it will execute them. And then we'll get these green check marks for the tests that passed, and we'll get red marks for any tests that failed. Let's go ahead and write a second test just so that we can see one failing. Let's say that when we add 2 and 8, we expect to get 5. Run the tests again. Clearly this second test is going to fail. So when it fails, we're going to get a display like this. It's going to show us the line where the test failed. It's going to show us the expected value and the actual value that it got. So we can see that we said we expected a 5, and when we added 2 and 8, we actually got 10. So we can use this to figure out what's wrong with our code. In our case, it's the test that's broken. 2 plus 8 should be 10. So we can hit that, run our tests again, and now everything is green. We also have the testing view over here in Visual Studio Code that shows us all of our tests. So you can see how long they took, which ones passed, which ones failed. If we go back and break this one again, we can hit run. Up here in this toolbar, we see that our test add 2 is failing. We get the same display in our code showing us what the expected value was, what the actual value was. We can use that to dig in and figure out what's wrong. Notice that when I'm running them from here, it's actually running the tests in all of my projects, which could be annoying. This takes a little longer than you would like. If we do this inside the code, then it's going to be a lot faster. Clicking on the checkmark for a test class will run the tests in that class. Clicking on the checkmark for a single test will rerun only that test. So when we're working on a smaller piece of the code, we can focus and make things move more quickly. Let's write a unit test for a little bit more complicated method. A couple of videos back, we wrote some code that was checking to see if a year was a leap year or not, and we decided that the code was a little bit too complicated to be sure that it worked correctly. This is exactly what unit tests are for. Let's say that we were going to write a method in our app class that determines whether a year is a leap year or not. So let's say public static, it will return a true/false value. We'll call it isLeapYear, and we'll pass in a year that will be an int. So here we're going to pass in the year, and it will return true or false, telling us whether that year is a leap year or not. I'm going to do this using test-driven development. So we're going to start out returning false. We just won't write any code until we've already written a test to exercise the method and seen the test fail. All right, that's what test-driven development is about. First we write the test code, then we write just enough code to make that test pass. Then we write a little bit more test code, and we update our code to make all of the new tests pass, and we keep going back and forth like that. This actually leads to simpler code and allows you to attack problems that are too hard for you to solve if you tried to just sit down and write the code. Let's add a test, and we will call it test isLeapYear. The first test could be app.isLeapYear, and we'll pass it a regular year that is not a leap year. And we expect this to be false. When we're checking Boolean values in a test, we don't use assert equals. We have special assert methods for true and false. We also can add some hint text when we use these assert methods. And this text will be displayed when the test fails. We need to import our assert false method just like we did with the assert equals. Quick fix is the easiest way to do that. Oh, and I've got this backward. The hint goes first. So we're going to pass in a string that will be displayed if the test fails, and then the true/false value that we want to check. I can do this all in one line, or I could have called app isLeapYear and assigned that result to a variable and then checked it in our assert call. Doesn't really matter. Here we should describe why the test is failing. So this text will not normally be displayed. It's going to be displayed if the text failed, and that means we should say 2019 should not be a leap year. So if this returned true, then the text that will be displayed is this. And that will be helpful for whoever is debugging the issue. So let's go ahead and run the test in this class. This test is going to pass because our is leap year, we had it returning false. Let's write a second test. This time we expect 2020 to return true. So we'll say is leap year and we'll pass in 2020. If we run this test, oh, it doesn't compile. I forgot to fix this error. So we need to import our assert true. We could just remember these import statements, or we could copy and paste them from somewhere else, but that quick fix is a pretty easy way to do it. Now if we run our test, it should fail. All right, so we failed on this line. We can see that our assert true did not succeed, and it's displaying the error that we put into our code. So it's saying 2020 is a leap year. That's our assertion error. So app.isLeapYear should have returned true. Let's fix our code so that 2020 does return true. So we come back to our app code here. We need to check if our year is divisible by 4. So year mod 4 is equal to 0. Now years divisible by 4 will return true, and years that are not will return false. Notice that we can return this directly because it's a Boolean expression. This expression evaluates to true or false, and our return value is true or false, so we can return it directly. Lots of people, beginners especially, would write an if statement here, and they would say if year mod 4 equals 0, then return true, because this is a leap year, else return false. You can do this, and this will have the same result as the code we had before. But this expression itself is already true or false, so we can just return that instead of writing this whole if. This is much more idiomatic Java to return the expression directly. Let's run our test again and see if we fix the problem. Okay, it passed this time. So 2019 returned false, 2020 returned true. Let's add another test case. The year 2000 should not be a leap year. Wait, no, it should. See, it's confusing even to remember these. 1900 should not be a leap year. So we'll add a test for that. And we should always run our code and see the test fail to make sure we're testing what we think we are. So we see the test fail. That means that case is not yet handled. So here we should say a year is a leap year if it's divisible by 4, but it's not divisible by 100. So I'm going to add an and here and then say year mod 100 is not equal to 0. Remember, this year mod 4 is dividing by 4 and taking the remainder. If the remainder when we divide by 4 is equal to 0, that means the number was divisible by 4. Here we're saying divide by 100 and take the remainder, so if the remainder was 0, the number would be divisible by 100. And we're saying that years where it is divisible by 100 are ruled out. So we want to say the year divided by 100 has a remainder that is not equal to 0. If we come back and run our test again, I think it's going to pass now. And then let's write one more case. It's going to be another assert true. So 2000 should be a leap year, even though it's divisible by 100. We'll run our test and see it fail. And then we can go fix our code. And if you remember before, this is what we had. 400 is 0. So it's a leap year if it's divisible by 4, and it's either not divisible by 100, or it is divisible by 400. This should make our test pass. All right, so these 4 cases work. Those are the 4 that we kept testing with last time we looked at this problem. We can add a lot more cases here. The big advantage of this over what we were doing before is with the original code, we needed to input data from the user to find out if we were getting the correct results. So every time we changed the code, we needed to go run the program and enter a bunch of different years and see what the output was for each one to see if things were working correctly or if our changes had broken the code. Now we can write this test and it expresses the correct results for each of these years. And now that this code is here, we could keep this test around forever. If there are ever changes made to the isLeapYear method, then these tests will run and tell us if it's still returning the correct results for all the things that we checked. It's also really easy to add a bunch more tests. So we could drop in some other years that don't divide by 4 evenly, 2001, 2009. We need to update our comments or we're going to get some misleading error messages when these fail. But this is cheap. We can add these tests, and now every time in the future that we run our tests, all of these values are going to be checked. So we can add any corner cases that are almost leap years, not quite leap years, following whatever rules we want. And once that has been expressed in the test, we know that if we have a regression, if we make a change to our code in the future and it breaks something, we'll find out about it right away when we run our unit tests. So there you have it, a quick introduction to methods and unit testing. We looked at how to define a method, how to call the method, how to pass parameters into the method and get return values back, and then we took a quick look at unit testing. Now we can define a bunch of assertions in a unit test, supply inputs to our methods, and check that the method is returning the correct results in each case. Next time, we will dig into classes and objects. Thanks for watching. Don't forget to like and subscribe.